So as I've previously mentioned a few times in a few of the other videos, network protocols are used in any type of network in order to send data from one place to another, or even enforce other data rules depending on what is needed. So TCP/IP is the main two protocols that's used in networking, so that's for transferring data. So TCP is the packet of what's being transferred, and IP is the protocol that's being used to determine where computers are logically on network, so the address of the network. So the IP protocol is the address of where it's going or being sent from, and TCP is the actual packet with the data in. So TCP/IP is quite a commonly used network protocol. Now, obviously, without these protocols, if one computer had the protocols on and another computer didn't, it would send all this data through, and the other computer would be like, I have no idea what this data is. It's essentially protocols are like languages for computers. So not so much programming languages, but more networking language. So if you were to try and communicate with somebody over a large distance, so say you were doing it via um, say flashes of light, and you worked out systems such like Morse code, if someone else doesn't know what that is, you can't communicate with them, because how can you? Because they don't know what it is. It's just flashes of light. They'll be like, I have no idea what this is. I cannot decipher it. So, same for computers. You need protocols in order to transfer data from one place to another. If they don't both have the protocols on, it cannot transmit data. So protocols can do all sorts of things. So it's not just about literally just transmitting data. So it can control the speed of data, can control error checking of data, the type of data that's sent. Obviously, the structure of the data that's sent. It basically governs everything. So these protocols are made by the Institute of Electronic and Electrical Engineers, which I've mentioned before, the IEEE. They come up with all these protocols. They say, right, this is the standard for all these devices on the internet, for different manufacturers. Like, you must use these protocols, otherwise this is not going to work. We've designed these in a way that they are efficient and they work with each computer, hence why they're used in networking. It basically lets the computer know everything they need to for a particular set of data coming through. So it can see this data coming in, decipher it, and know, right, it's TCP/IP protocol being used, or POP3 or DHCP being used, and it can go, right, I know what this is, I know what to do with this data, and it can carry on taking the data then and go, right, I know what to do with this, and then obviously execute calculations based upon what it's sent. So, um, you know, protocols are quite common in a lot of machines now. There are some machines that don't really use protocols, and you have to basically use serial connections and stuff in order to transmit data between one another. So it doesn't use protocols; it just does it via synchronous transmission and asynchronous transmission. It doesn't do it via protocols. But that's been phased out quite quickly, because protocols can stop errors, that can make things faster, more efficient. So protocols are, well, that's why they're used in real life as well. That's why we have protocols. So the whole reason we have protocols, say for, not keeping. So one of the protocols at college, which is an obvious one, but I'll point it out nonetheless, is not blocking the fire door. And the reason for that protocol is because, well, if there's a fire, how do we get out? Because it's blocked. So same sort of thing for a computer. It has these rules in place to keep data safe. It's the same thing. So if you didn't have these error checks in place for protocols, or protocols for error checking, something could be majorly wrong, and then obviously things could crash, and obviously start to files get damaged and stuff. So same sort of concept. So that's network protocols, and that's basically the first part of transmitting data, part E. As always, I always put key terms at the end of my PowerPoints. I was going to say videos then, but on my PowerPoints there are key terms. So if you want to have a look at them, I have sort of mentioned all of these already, but it's something, if you want to sum it up, I've put them at the end here so you can see them. But basically that's part E, transmitting data in computer systems.